What's going on, guys? Zane here, back with another video. For this one, we have the are similar problem on CodeSignal. Two arrays are called similar if one can be obtained from another array by swapping at most one pair of elements in one of the arrays. Given two arrays, check whether they are similar. So for the example here, if A is equal to B, so the vector 1, 2, 3 is equal to 1, 2, 3, then of course it will return true because they're exact. For this example here, we have A is 1, 2, 3, B is 2, 1, 3. Although they are different vectors, if we were to swap the first and second element of B, then we'll get 1, 2, 3, and that is the same. That will also return true. But for this third one here, if A is 1, 2, 2 and B is 2, 1, 1, then this will return false because even if we were to swap these two, it will then be 1, 2, 1, not 1, 2, 2. So let's write a program that will tell us true or false, yes or no, are they similar or are they not. That's why we have a bool type function here, and the function is being passed in two vectors, which is A and B, which is right here, A and B. That's it. So I'm going to create this program in Sublime just because I think it's easier to read and I can zoom in without all the other stuff popping up. So let's first include any of the libraries that we're going to need. I always include IOStream because that's just my default library. I know we're going to be using vectors, so we'll include the vector library as well. Let's start off our main function. And now in here, we're going to need test cases to test our code. So let me just take one from here. Let's use something more. Sure, let's use this. Cases here. Let me do some formatting real quick. So we're going to be making two vectors of type int. It's the same thing here. They have standard vector type int. This is stuff that they gave us. So I'm just going to recreate it here. 114. So A equals 114. And then this is 1, 2, 3. So standard vector type int. B equals 1, 2, 3. And that's it for our test cases. Let's just run this, make sure nothing's going on. Cool. Okay, so to first tackle this problem, let's first figure out how many times we would need to swap, and then using that number, we can calculate if the program should return true or false from here. So we wouldn't have to go any further, we would just kind of stop there because we're swapping too many times. If we go back to the problem, we see here, yes, right here, swapping at most one pair of elements. So we're only allowed to swap one pair only once. So if we can create some sort of variable that keeps track of the number of times an element in the same index as both of these vectors does not equal each other, then we can get an idea of the number of swaps. So what I mean by that is, let's first create a counter variable, set that to 0, and now let's loop through any of the vectors. I'll just do A, so for int I equals 0. Wow. If the element at I for A does not equal the element at I for B, then we will add to our counter. So let me explain that. We're looping through A, and then for every element in A, we're going to use the same index position to check, does the element at I equal the element at I for B? So again, if the ith element of A does not equal the ith element of B, then we add to our counter. That's all we're counting. The number of times the array's values do not match. So now that we have that counter, what we can do is we can write a piece of code here that will essentially tell us, or tell the program to return false if the counter is higher than a certain number. So to get that number, let's first visualize how this would work. So if we were to take this number and swap them, that would mean that one swap would add 2 to the counter. That is the most subtle concept that I actually had a lot of trouble grasping. And if we were to swap at any point, that will affect 2 numbers because we're taking those values and switching both of their indexes essentially. So that's why we're saying when a swap is made, the counter essentially should have a 2. Now, if there's any number greater than 2, that means that we are swapping more than once. So again, if we have a counter of 2 or more, we are essentially swapping more than once. And that's something that is not allowed. That is a foul. So we can just say if the counter is greater than 2, then return false. We're done with the program. Because we're not allowed to swap more than once, and this accounts for that. So now that is out of the way, we're going to be able to write the rest of our program. That is assuming this has not returned false at this point, meaning the counter is less than or equal to 2, and that's okay, because one swap will be 2. So anyway, now what we want to do is let's sort the arrays so that we can start working with the rest of the code. So we'll do a standard sort. We'll do a.begin, comma, a.end. Now we'll do the same thing for b. So we'll do b.begin, and then b.end. Let's run this code. Sort is not a member of standard. We forgot to include a library, which is the algorithm library. Now let's run this. No errors, okay. So now that we have it sorted, and now that we've also assumed that we're gotten to this point of the code where it has not returned false, meaning we have only swapped once or less than once, which is either 0 or 1 time, that means after we sort, and if the elements are still not in the order or not in the correct similar order, then that means we just return false. So what I mean by that is let's first write our for loop again, and it's going to be the same for loop as the one that we had above. So if a at I again does not equal b at I, then we return false. So if we sorted these, right, that means that this over here will be 114, so this will be unchanged, this will be unchanged. So assuming this did something, and let's just for this purpose assume that this is now the new sorted 2 vectors. If these do not equal each other, then that means even after we swap any of them any number of times, that this will still not work. This will still not be the similar vectors. These will not equal each other because we sorted it. So this will tell us, will it ever be true? Will these ever equal each other? After we sort, we don't need to worry about swapping. So that means after sorting and these still don't equal each other, then we return false. And that's what this did here. Now we're at this point where we've established all the times that the program should return false. And if it's gotten to this point, that means all of the falses are accounted for. And now we just need to return true all the way outside of everything. Because after all this is done, if this was not the case, and if this was not the case, we need to return something else so that it ends the program. So since this, let's say that it was equal to each other, and this was less than or equal to 2, then we just return true. So now let's just copy all this code here up to here. Actually, we don't need the vectors. We'll copy this, go into here, run the tests, and there we go. So I know this one was a little weird in terms of how we did it, but the way that I was able to easily learn this problem was to kind of just break it down into how we can get it to go wrong rather than how do we get it to go right. So that's one of the biggest advices I can give to you is that advice? My biggest advice to you is don't just try to get the true value. If it's saying are similar, you would probably be like, okay, yeah, we're trying to make them similar, so we're trying to get true. Yes, that's true. But we're also trying to get false, right? Because it could either be true or false. So what I'm trying to get at is don't try to just tackle the problem by seeing how do we make this true. See if you can get it the other way around. If you can try to make it false, then you can go through all of the ways that you can get false. In this case, there was this way, and then there was this way after sorting. So there's two ways we can get false, and then if none of those two actually occur, then we just return true, because there's no other way it would turn false, so the rest must be true. Anyway, that's it for this one, guys. So if you have any questions, comments, or feedback, please let me know. Otherwise, like this video, hit that subscribe button, show me some love, and I will see you in the next one. Peace.